17 is 28, but a minus 17 is negative 6, right? And we know that 68% is between those two numbers there. Okay? We want to know, in this case, what's the probability that it exceeds 10%? So we want this area to the right. Okay? You're recording? You can send that to me. I will post it. That'll be good.
Perfect.
And Sarah would appreciate that. And I would appreciate it too. Most people like that. Don't record me. Anyway, okay, so how do we do this one? This is P1? Yeah. We want it to exceed P1. So we need to find out the z-score for this, right? We're going to use this equation. Okay. So it's going to be, we want it to be 10% minus 11% over 17% over the square root of 40. Okay? So that's going to be -1 over, I don't know what that is. But you guys need to practice this, so we're going to pull this up in Excel. That means I don't have to do this later. I'll do our recording in Thunder. Oh, I didn't sign in. So we got a busted computer too already? Not busted, do we know that?
Yeah, it's like this blue screen that would pop up.
Okay, well, I will be playing and skipping out. Are there any others that are busted? Do we know? This one? These two are busted?
And that one.
And that one? One's a screen?
I don't know. This one even let me log in. Like I log in and comes up, but when I go to log in with my information.
Okay. Well, okay, so we're going to do this. Equals 10 minus 11 equals 17 divided by the square root of 40. And I'm going to divide the numerator divided by the denominator. I get negative 0.37. So we just converted this. So we're negative 0.37 standard deviations away.
Why did you take the negative 0.3? I have the first two.
So 10 minus 11 is -1.
Yeah.
17 over the square root of 40 is 2.68.
Yeah.
Something whatever. And I just divide those two and I have a point to stuff. Okay? Yes.
Sorry, I'll be passing with the score of it.
Oh, that's what you always do. It's in parentheses, though. Put the 40 in the parentheses. Okay? And then, yes.
Sorry, with that, do we put the number in the parentheses as well?
The 40 in the parentheses.
Before the parentheses.
The 40 is inside the parentheses.
Oh, okay.
Yeah. Just like I did that. Okay? The blue equals. I didn't put the equal where it would go at. All right, so you should all get 0.372. Okay? Now, there's two ways to look this up. We can look it up on the table, but since we have a computer, which is really recording this, thank you. Okay. What we can do, actually, let me point this out really quickly. I posted this morning because somebody texted me and said, oh, we don't know the formula. And so I was like, oh, I forgot to post the formula sheets. So I don't think you're going to need this today, but I'll give it to you. So,
if you click on the link, it should pop open in your browser.
Oh my gosh, this house. Anyways, so this is going to be the formula sheet that we're going to use for the rest of the semester on every test and probably for the quizzes here on out. It's a one-page formula sheet. If you haven't got formulas, you're not going to need yet, but we will use it. I want to create 15 formula sheets. So these are all of them. You've got your population standard deviation, your sample z-score, your population z-score, correlation coefficients right there, upper and lower fence, equation of the regression curve here, your mean. We don't need that one. We're going to be using, after this test, we're going to start getting into confidence intervals. Don't need that for this test. We'll do the next test. We're also going to do a hypothesis test. Don't need that yet, but you will. Although it does have x bar minus mu over sigma over the square root of n. So there we've got that, which is very similar to that. But you probably will need that. Anyway, chi-square test, which we don't have. And then at the bottom, we've got Excel commands. And so these are all the Excel commands we're probably going to use. I don't think there's any on there that, I forgot quartile. You remember quartile. I guess you'll have to remember that one. I forgot to put that one. But at any rate, which of these commands am I going to use to figure out the purple area?
And is it the norm distribution?
Norm is this, right? Now, the question is, in Excel, is norm as this going to give me the purple area or the white area? You give you white area, okay? So norm as this of that. Okay, so the white area is 0.354. How do I get purple area? Just one minus. One minus 5. So the probability of exceeding 10% is 0.645. Okay, that makes sense? You can ace my test on Thursday? Yes.
It's not letting me type in Rumus test. It's seeing there's a bunch of too few arguments.
There's a part of that is like the true. Oh, you put the period. Don't put the period. There's two commands. One of them has periods, one of them doesn't. The one that doesn't is the easier one to use. If you use the one that does, I can't remember, put true or false, put comma, true or comma false, and it'll give you the same answer. But the one without the periods is easier. Yes.
Might also coming up with an error says this function is unavailable for conversion. Yeah.
You can see. Around. That's just I have it right there.
Oh.
Click. Okay. I don't see. Now you can move the negative one out. I think this is why we're doing this, so you guys can practice. Okay? All right. Any other questions? Last cigarette?
Could you just remind me, what on the discrete use, what does NP mean?
N is your sample size. P is your probability. So if this were discrete, if this was a approval rating, let's say, and so 0 to 100 is all you can get, you could actually get more than 100%, right? In this case. Well, let's assume that it's approval rating at 0.1. So you would do N, which is 40, times P, which would be 0.11, and Q would be 1 minus P, which is 0.89. In this case, that was the 3 times 0.89, okay? And I got 3.96, okay? So my question to you, how big should a sample be to be normally distributed? Assuming this is, so we got, what did we get? 3.916. Is this sample of 40, is it large enough? No. Okay. But since it's continuous, it is large enough. Okay, does that make sense? You can explain what is it? It's the first question. I just wrote. Okay. All right. 1 minus 0.1. Oh. So P is your, another way to think of this, P equals your probability of success, and Q equals your probability of failure, which is 1 minus success. Okay? I don't think I gave you any problem on this one on the homework. I think of what there should be. Okay? Only 4 questions. It's easy. Well, I think it's easy. You might know. Okay? Alrighty then. Trying to think if there's any more. Oh, you know what? Oh, I know. That's not formula sheets. Okay. I will. This all. I'm going to pass out the quizzes now. You can use your calculator. You don't need to use your computer. I will also pass out formula sheets and tables. We got 2 graphs, a histogram, box and whisker, outliers, standard deviation, 5-number summary, z-scores. Each one of these tabs at the bottom is a different homework problem. And I basically went up through regression, which is chapter 5. There probably will be some I didn't put chapter 12 and 15. I can put those on later, but we did go over that at the beginning of class. So anyway, let me first ask you, based on that's like a lot of problems. You'll probably have 3 or 4 problems. I'll probably pick one from each, maybe 5. One from each chapter. Based on here, so this first one, let me go to this first one. Higher education includes 200,000 first-time freshmen who entered in college 2015. The survey is the students used to pay college expenses. So, first question is, what would be an appropriate graph for this? And secondly, would you know how to create that graph in Excel? This is question 1.04 for now. Make me proud, Sarah. Dear Abby.
I'm sorry, I just zoned out completely.
Okay, Haley, do you know how to do this?
What if you have histogram?
A histogram. Who agrees this a histogram? 1, 2, 3. Who disagrees? Brooke, what do you think it should be? I think you were disagreeing. Were you? You're the only one.
Yeah, sorry, I was trying to log on.
Oh, you disagreed and you didn't even hear the question. David, what do you think? Is a histogram a good idea to this?
I'm also trying to log in the first. But yeah.
Histogram is a bad answer.
It is not.
Would you say?
Histograms have to add up.
Something has to add up to 100, but it's not a histogram. Pie chart has to add up to 100. Does this add up to 100?
No.
No. So would a pie chart be a good choice? No. Histogram is a bad choice. What's another choice? What? Either a bar graph. Okay. So do you know how to create a bar graph in Excel? How do you do that? Have you? She's Sarah. Keep wanting to call you Sarah.
Well, you would put those numbers in the line thing. Oh, perfect. Yeah. And then you would just go to insert. And then you just go over to those lines. Yeah.
Okay. Now there's 2 ways you could do this. You could do a vertical line graph, in a bar graph, or you could also do, and this would be perfectly correct, for horizontal. Both of those are fine. You could argue which one. If you put it in order, are those in order? If you put them in descending order, what would it be? No, that would be called. You could data and you sort it descending. Okay, now we just turned it into a Pareto chart. So family resources is number 1, A, not be repaid, still resources, and A, to be repaid. Okay? How many of you feel comfortable doing that on Thursday? 1, 2, 3, 4, 5. You got a figure from you? Okay? All right. I will post these as answers after class. Okay? So the other thing is we probably should put in access titles. This one you probably could get away with it. Okay? But especially for you people that have Macs. You know how to do access titles on these computers still. I hope nobody's using a Mac or a Chromebook. Oh, William, you were the Chromebook guy. You should be practicing.
I practiced this on a lab. Like,
Mhm.
that's what I did this
Okay.
weekend.
You guys know how? How do you do that? Mackenzie. So you click on it one time, you click on the plus side, and you do access titles. Okay? Now, it doesn't work that way on the Mac. So you could put, you probably don't need this one. This one probably be pretty good. What is it? And then down here, you can put type of financial support. And up here, you can change it from students to 200,000 system financial. Okay? Does you all know how to do that? Sure. I have another one here, but I'm going to skip that one. Maybe I'll leave that one for you to do. Now, this one's called a histogram. Now, why? Well, this one is a histogram. Now, I don't really like the way they did this. This is a homework problem. Can you explain to me why? First of all, what is this called? What is this table called? Euler. Anybody know? Shanley? Make me proud?
Oh, okay. It's like the whole
Table.
tables,
With him?
a frequency table.
Frequency, I would call it distribution, but you can call it table. Distribution. Okay? Now, why don't I like this distribution? What's wrong with it?
It includes numbers twice.
Right. Where's this 20 go? Does 20 go here? Does 20 go here? Okay? Now, when you have software, it's not too bad, but this so think of this as almost 20 and 20 and above, I guess. I don't know. I don't like that the overlap. So when you do this, you shouldn't overlap them. But how do you create a histogram? You're going to highlight the table. But this is going to be a lot like the bar graph that we just did. We're going to do insert. You're going to grab the bar graph and do the 2D bar graph. Okay. Now you're going to go to, and this is going to be very important because I think I couldn't remember how to do this last time. We're going to go to quick layout. Okay. Not a histogram because the bars aren't touching. We want the bars to touch. And that one right there. Okay. Second row, second column, third row. Now the bars touch. And the nice thing about that is it tells you need to put in these. So what is my axis title right here? What is this? Page of mother. Yes. And this is number of children in thousands. Now that's kind of weird. let's come with that way. This is verse in 1980, a night going in one verse place. Okay? And the weird thing is we need to really add 3 more zeros to there. So this is not 500,000, it's 500 million. Okay? All right. Does that make sense? I've only got 2 minutes left, so I kind of want to go really fast. I hate to do that to you guys, but there's another histogram for you to practice. This one, you're going to have to create your own frequency distribution. You'll probably want to sort the data. Do you guys know how to sort data? Okay. The easiest thing to do is highlight the whole table. Okay. And then I'm going to go data. And notice I included the state and the percent. Okay. I'm going to click on sort. And I want to, your data has headers in this place. I want to sort by the percent. And whether you go smallest to largest or largest to smallest, I don't really care. But then you're going to have to create your own frequency table that's already here, like this one. You will have to create it and then create your histogram. Okay? Box and whisker. Remember how to make a box and whisker? No. Haley's got a big no. Okay? This one's interesting because it's in row. You're going to highlight your data. You're going to go to insert. And I don't see them there. There's a box and whisker there. If you click on that, or you can do recommended charts. Recommended charts is nice because it gives you every kind, and you can go as box and whisker here. That's a bad sign. Why is it not giving me the data? Oh, it did. Okay. Well, there's your box and whisker. Probably should add your axis titles. What are these? These are tulips. And different types of tulips. Right? Tulips. Really don't need an axis title on this one. And this is measured in centimeters. Okay. I'm going to assume you know how to find your quartiles. Maybe I should do that. These are good recommended charts. You're doing about anything say in?
It's not as well. It's
I don't think you that in the turn off the lightning. And you're using the Mac versions and then video features. Maybe that's not really. Yeah. I can't see it from the What's this?
I don't know what I do. It's just something. I don't know.
Yeah, well, I'll work with you after class. I want to make sure we do it going here. The quartiles. Let me put quartiles there. That's the formula equals quartile. We're going to use the one without the thing. You'll highlight this as your array, comma, and then you pick your first quartile, for example. Okay? Just wait for this. Outliers. Do you know how to find outliers? I want to concentrate on the stuff I'm not going to know. Here's the thing. Okay, standard deviation. Well, this was really lengthy. I'm trying to do stuff that, I need to do this one. Okay, so the Z-score, you guys remember what formula you're supposed to use on this one? Z equals X bar minus mu. I've received my English then. Okay. So we've got heights of women. Let's go mean mu equals 64.2. Standard deviation sigma equals 2.8. Heights of men. Well, we're going to worry about that in women. Sorry. I'm going to do part B. Women are greater than 5.5 feet tall. Okay. So 5.5 feet, this is in inches. 5 times 12, 66 inches. So we really care about 66 inches tall. Okay? So we're going to do 66 minus 64.2. That's your numerator. You're going to do a divide, which is 2.8 divided by the square root of. Now, does it give the n? No n, right? So what do I assume my n is? 1. Okay? And I can always use this formula no matter what. I'm going to get this divided by that, which is 0.642. Okay? That's my z-score. Okay? Now, how do I find my p-value? Or the probability. We want the percent of women that are greater than 5.5 feet. Now, you will have your formula sheet, so you can look at your table if you want to. However, if we're using Excel, the table is going to be just like Excel. As you can see, the table gives you to the right. Do I want to the right or do I want to the left? This is where a piece will be helpful. Okay? To me, it's 64.2. I want 66. I want the area to the right. I think I told you that wrong. Table's giving me the area to the left. So how do I get the black area here? Say louder.
The 1 minus the.
Yeah. So I'm going to do p-value is going to be 1 minus, and then you can use the formula norm as this. Okay? Because norm as this gives you the white area, this gives you the black area. 1 minus norm as this. I'm going to put that number in there, get up to my z-score. I'm going to get 126 So that's my answer. I'm going to blue as in yellow. That's part B.
Would you not want the area left of it since it looks to find what's the chance that they're less than? Oh no, it's great.
It's just really yeah. Depends on which question you're looking at. The next question you're going on less than, then you can just take it as X.
Okay.
No, it's 1 minus the norm as this of your z-score. Okay, Beth, here's the tricky part. I'm going to put this in red or orange. Okay. A lot of you are going to look at that and you're going to say, oh, that's 64%. But it's not. We converted 64 to 0, and that's 0.64 standard deviations away. Now, if I had gotten, let's say this was 4.8, you would not mistake that for a percentage, would you? Okay, because it's greater than 100%, right? That's a z-score. But the problem is when you get a number that's less than 1, like we did in this case, a lot of you are going to think that's your p-value, and you're going to subtract it from 1, and you're going to get 36%, which is going to be the wrong value. Okay? So that's why I labeled it. This is your z-score. This is your p-value. Now, we're technically out of time. I can go for another half hour if you would like. I will have to leave in 30 minutes, though, which means I won't be able to talk to William. But,
Do you want me to send them to you on Canvas, the videos, or? Yeah. I can either put it into a Google Doc and sheet it like that, or I can
Google Drive.
Google Drive, either or.
I'll send you a link. So send me an email, or I'll send you a link. We'll have you copy it up there if you can.
Okay.
I'll post it. I will be posting it on YouTube. Once William gets it to me, you can look at it.
Perfect.
All right. I know we're going a little fast. You have to leave. That's all. Check out the YouTube later.
So much. Thank you.
You're welcome. Let's see. Look at this videos. Standard deviation. I would love to do a standard deviation. I have a feeling it's just a big too long. It would be nice to do it. I didn't know I don't get you to create a post of it. You know how to create a scatter plot. David, do you know? I will do that.
It's gonna be very nice. And then I like this one.
Yeah.
Now, the first question is, based on this, we should calculate the correlation coefficient by hand. Is going to take me too long, too. I'm going to focus more on graphs. If I could give you a little bit of time, I would make you do this by hand. Well, it says, how do you find out without doing it by hand? You know the cheating method? What? Cool. And then you do the x values first, comma, the y values. Okay? So I got a negative 0.92. Now, the first question is, based on the scatter plot, does linear regression look like a good idea? Yes, it does. That looks like a very straight line, right? Okay. 0.9, negative 0.9. Sarah, is that strong, moderate, weak? That's very strong, right? 0.9, that's very strong. Is it pure correlated? Yes. Can you find the least squares regression line? Now, that's something I would make you do on your computer. What is the basic format of the least squares regression line? I am. I should have said I am. You can find it without doing it by hand. But I want you to find it by hand. You know how to do that?
Did you do y equals mx plus b?
Okay. That's the format. Y equals mx. Now, how do I find out the below from B? Formula for M is, on my formula sheet here, R times S of Y divided by S of X. And B is Y bar minus N times X bar. Right? You will have those formulas. You don't need to memorize them. Okay? Well, what this does tell me is I need to find my means and I need to find my standard deviations. Okay. Well, my mean is average of all this. The standard deviation is S continue to be of all this. And I already calculated my thing. Okay, so my M in this case, if you have my big phone, I have a big phone. I'm not getting the name. I hit them give us different places. For some reason, that helps me remember. Haley.
Can you zoom in a little?
Okay. Correlation coefficient is. She didn't want to call for Abby, but Abby's over there. Push me in.
Oh, yeah.
Annie. I knew it. Abby, and Annie. Close. Annie, what's the correlation coefficient? And 2 times. What's S of Y? This one. 1 by. No. Okay. And my slope in this case is negative 0.049. My y-intercept daily is what?
I don't
Know what your y bar is?
know, because I didn't get.
Oh, I put those on the wrong lines, didn't I?
I got stuck at the 52.
I did that really in a confusing way. Now that they're properly labeled, my y bar is
76.
how many sticks? Are you going to get this?
No, I said I got stuck at the 52.
76
I was turning off.
minus what's my slope? The slope I just calculated right here. 0.049 times what's that number? 2 there, right there. My bar is 1. Yes.
How'd you find on?
All right. Well, I achieved it. I used the choral function. I really would like you guys to do that by hand. You actually get to do a homework assignment sometime. But I've only got. Oh, by the way, I should mention this really quickly. I'm going to give you guys an hour and 50 minutes to do the test on Thursday. We'll do it in here. And so I don't think it'll take that long, but I'm giving you 2 hours. Basically, just short of 2 hours. Because I have another class. Okay? Yes.
Sorry, will you go over the R times SY? I'm just trying to put it in, and I didn't get the formula. That's all.
Okay, so put your formulas right here. R, we figured out right here. R times S, which stands for standard deviation of Y. This is your X variable, this is your Y variable, so this is your standard deviation of Y divided by your standard deviation of X.
Okay, that makes no sense.
Okay? Yes.
So are we calculating the correlation coefficient by needing? Do we need to understand that principle, or are we only doing the least squared regression line back?
Normally I do, but I also give you a little time, but I can only give it 2 hours. So I'm probably not going to make you do it this time.
When you're saying by hand, are you talking about like actually doing it on the computer or like writing out the formulas there?
So here's what I mean by hand. I'm going to have to insert a bunch of spaces. Okay, so when you found your means, oops, I didn't do that. Found your means and your standard deviations. Your formula, you're going to have to do the data minus the mean. Okay, here's what I'm getting by that. What this is going to be, basically you need to find this equals the data minus the mean of the x. That's for that. Okay, I'm going to do that for all of my data. Now I need to do it again for the y. Equals 79 minus 76. And that's for it. And now I need to find the z-score for the x. This is going to be the numerator divided by my standard deviation S4. Okay? I need to find my z-score for the y. It's going to be this number divided by this mean, which is here, F4. And then we copy that down. That's the list down. I can give this up to a 3. And I need to find the product, which is this number times that number. I'm doing this all. I probably should mention the formula. R equals 1 over n minus 1 times the sum of xi minus x of r over s of x times yi minus y of r over s of y. I've got that memorized. I'm sure you don't. That's your correlation. Okay. I will give you this formula. And what I mean by hand, you're going to take the data minus the mean, which is what I did here. And then I did the data minus the mean for the y's. Then I divided it by the standard deviation. I divided this by the standard deviation.
Yeah.
Now I'm multiplying them together. What does this mean? So I'm going to find the sum of this column. And I'm going to divide by n minus 1. What's my n? I didn't know. So my n is by n. What's wait a second. Something's wrong. Or did we find correlation coefficient? I thought that was wrong. That should be 0.92. What was wrong? A minus the mean. A minus the mean. Divided by the standard deviation. Oh, that's right. Oh, I divided it wrong. That's why. This column is wrong because I divided it by the mean instead of by the standard deviation. That's the divided it by here. All right. Okay.
And when you did the sum, you only did the very last row?
The column.
The column, yeah.
Mm-hmm. Okay. So that's what I mean by hand. Okay. Now, I just did that. I don't think you're going to have enough time. Do I want you to know how to do that? Yes, I do. But that's what I mean by hand. Okay.
I need to run to
Usually I make
class.
people do it by hand, and then I say, give me with the real answers, and you can do the rest of the problem, right? Because, I caught where my mistake was. But a lot of you are going to be like, no. Okay. Let's see. Oh, regression. This one, I think it says, this is the same thing as that, basically. I did a lot more there, but, so we did, regression line. So actually, we didn't finish this. What is a, now that we've got all these calculated, can you give me the y equals mx plus 3 line? What's the equation that this should be? Y equals
0.0492.
negative 0.049. That's good enough. F plus 29 minus 6. Okay? Now you can check your answer. Do you know how to check your answer? Pick a point, any point. Once you're using the math, won't work. Right click and say add trend line. And then say display the equation on the chart. And you can also display the x squared, which you don't need. And I'll put that there. And look, my answer is what they got. How about that?